Assalamualaikum and a very good morning. So this is the last part of the third chapter, Fourier Transform. So I will be discussing some examples based on the past year's test and final exam question. Okay, let's look at the first example. There are two sub-questions in the first example. So you need to determine the Fourier transform of the following signals. So the first thing you need to have in hand is the Fourier transform, pairs of Fourier transform table. Okay, the first question 1A. So in answering, make sure you write your question number properly. Question 1A. So you need to have your Fourier transform table or Fourier transform pairs in hand. Next step, you need to compare the given equation with any equations in more or less similar shape with the given equation. So for this particular case, you can notice that there's a combination of ft with cosine function and also t multiplied with exponential function. So this equation can be rewritten as xt equal to ft cos omega naught t. So in which your xt, your omega naught is equal to 4 in this case, equal to 4 ft cos 4t. So in which they will produce x omega equal to 1 over 2 x omega plus 4 plus x omega minus 4. Okay, so this is the first equation. So next, what is your ft? So what is ft? So in this case, ft is equal to this. So ft equal to te minus 2t ut. So from the table, you know that, okay, from table, you know that te minus at ut will produce 1 over a plus j omega squared. So in this case, we know that your a is equal to 2. Therefore, f omega equal to 1 over 2 plus j omega squared. So this is equation 2. So now to solve the equation, the main equation is xt, so you'll get x omega. So from, you need to replace 2 to 1. So in this case, it's supposed to be f. Okay, x omega equal to ft, so this is supposed to be f. So it's f plus f. Okay, so you need to replace equation 2 into 1. Therefore, your x omega equal to 1 over 2. What is your f omega? So f omega equal to 1 over 2 plus, the first one, all omega must be added by 4. So 2j omega plus 4, don't forget to square them, plus, and then another f omega is 1 over 2 plus j, but the omega must be minus 4. Don't forget to square them. So then you can simplify the equation. So x omega equal to, so simplify the equation. You don't need to solve them, but just simplify the equation. Okay, now look at the second example, question 1b. So given is the sinc function in t. So from the Fourier transform table, you know that the rectangular function will be in t, but the sinc function will be in omega. Therefore, you need to use duality concept. Okay, from the previous Fourier transform properties, I have discussed the duality properties. So in which, if you have a in normal practice, rectangular t over tau, tau is the width of the rectangle, will produce a tau sinc function omega tau over 2. But now you have the equation in sinc function. Okay, so in sinc function, but in t, so a tau sinc function t tau over 2 will produce 2 pi a rectangular t become negative omega over tau. Okay, so compare the given equation. So in this case, you have yt equal to this equation. So now compare the given equation with general equation. So you have 2 sinc function 5t divided by 2. So this one will be 2 pi. So what is your a? So in this case, if you take note that a tau equal to 2 and tau over 2 equal to 5 over 2. Okay, so tau over 2 equal to 5 over 2. So your tau equal to 5. Next, a tau equal to 2. Therefore, your a equal to 2 divided by tau. It is equal to 2 divided by 5. So now your a is 2 divided by 5 rectangular negative omega over your tau is 5. So this is your y omega. Therefore, your y omega equal to 4 pi over 5 rectangular negative omega over 5. Okay, look at the second example. Second question. Find the Fourier transform for the given signal gt in terms of sinc function using the information provided in the table. So you need to refer to Fourier transform table. So to solve this kind of question, first you know that these are the superposition between more than one rectangular signal. So you have flexibility to choose whether to consider this signal plus this one, 1 and 2 and 2, or you can also consider this one, 1 and 2 plus 0 to 2 and 2, or you can also do multiple operation, 2 and 1 plus 1 to 2 plus another one, 1 and 2. Okay, so you can choose either methods, okay, whether method 1, method 2, or method 3. It depends on how you derive your rectangular equation. Okay, in this example, I would like to divide this GT into combinations of G1T and also plus G2T. Okay, so you need to write the equation of g1t plus g2t. So to write a rectangular equation, don't forget to refer to the reference of rectangular function. So the amplitude is a, so this is tau over 2, negative tau over 2. So the width is basically tau. This represent a rectangular t over tau. So therefore you need to compare, okay, the reference rectangular should be symmetry at y-axis. So it is half on the right hand side and half on the left hand side. So if compared to the signal that we have, all signals are on the right hand side, meaning that the reference signal, the reference rectangle has been shifted to the right by certain t. Okay, therefore you need to consider the shifting, the time shifting as well. So in Fourier transform, if you refer to the table, so if you have shifting in time domain, so there will be multiplication with exponential function in frequency domain. Okay, so let's start writing the g1t equation. So in this case, g1t equal to a, the magnitude is a rectangular t over tau. The tau is 1, the width is 1. So this is a tau for g1t. But if you compare this rectangular to this rectangular, you may notice that this signal, so originally like this, 0.5 and minus 0.5. Now 0.5 have been shifted to 0. Okay, meaning that the signal has been shifted to the right by 0.5, so negative 0.5. So this is your g1t. And g2t equal to, the magnitude is 2 rectangular t, the width is still 1 divided by 1, but the signal again has been shifted. Okay, the width is 1, so originally like this, 0.5 and negative 0.5. Now 0.5 has been shifted until the new location is 2. So this one now become at this point. Okay, so t has been shifted by 1.5. Therefore, for g to t, the shifting, the t naught is minus 1.5. Okay, so next, to convert each of this into omega. So your g1 omega, you know that a rectangular function, a rectangular t over tau will produce a tau sinc function omega tau over 2. So for g1 omega, so your a tau, so your a is 4, this is your a, and the tau is 1, this is your tau. So a tau sinc function omega tau over 2. But since that's shifting property, so shifting property meaning that your g omega must be multiplied with exponential function e j omega, your t naught, the shifting property is 0.5. This is your t naught, so 0.5 or 1 over 2. So this is your g1 omega. And then your g2 omega equal to a tau, so a tau sinc function omega tau over 2. And this shifting property, t minus t naught, so your t naught is 1.5. So refer to this equation, t minus t naught, so that's multiplication with exponential function. So e negative j omega, your T0 is 1.5 or 3 over 2. So the final equation, so your g omega equal to g1 omega plus g2 omega, in which it is equal to 4 e minus j omega over 2 sin function omega over 2 plus g2 omega 2e minus j omega 3 over 2 sin function omega over 2. So this is your g omega. Okay, let's continue with question 3. So given an linear time invariant system, so we have the input Vt multiply with a carrier signal Ct and produce the output Mt, and an Mt is sent into a filter given by the transfer function h omega, and you get the final output Yt. So first you need to determine m omega and the rest of the question. Okay, so the first one, you need to determine m omega. So what is omega? M omega is basically from mt. So what is mt? Mt equal to Vt multiply with Ct, in which this one equal to Vt. So your Ct is ej50t plus ej100t. So this one equal to Vt ej50t plus Vt ej100t. So this is your Mt. So if you compare to the table, when you have a function multiply with exponential function, so the Fourier transform of the signal equal to f omega minus omega naught. So in this case, you know that the e j omega t, so if compared to Vt e j omega naught t, so you may notice that you have the first omega naught and the second omega naught. So this one you'll have v omega minus 50 plus v omega minus v omega minus 100. So this is your m omega. So what is v omega? So v omega is from Vt. So Vt will produce v omega. So what is your Vt? Vt is the rectangular t. So you know that this one is equal to 1 rectangular t over tau. The tau is 1. So this one will produce a tau, your a is 1, the tau is 1, sin function omega tau over 2. So your v omega equal to sin omega over 2. Therefore, your m omega equal to the v omega, but all omega, this is the v omega. So v omega, but the omega must be having some shifting. So the first one is v So what is your v omega? So it is a sin function of the first omega, but having shifted, the omega being shifted by 50. So omega minus 50 divided by 2 plus the second component So V omega is sinc function, but the omega having a shifting by 100 divided by 2. So this is the equation of your m omega. Next, so this is question 3 part 1, and this one is question 3 part 2. Sketch the magnitude spectrum of m omega. So you have the m omega in sinc function shape, so the signal being shifted to the right by 50, so it is omega minus positive 50, so the signal both on the right hand side. So this one, so you have this sinc function centered at 50, and here is 50 plus 2 pi, and here is 50 minus 2 pi. Why 2 pi? If you remember the sinc function, how to plot the sinc function, it is basically 2 pi over your tau. So in this case, our tau is 1. And the second signal, we have another sinc function, but centered at 100. So it is 100 minus 2 pi, and here is 100 plus 2 pi. Don't forget the magnitude. The magnitude is 1 for both signal, and this is your m omega. And don't forget to label the x-axis as omega. Okay, next, question 3 part 3. Question 3 part 3. So state the function of h omega. So if you refer to this figure, so it is basically a filter. So you may notice that there's certain bands being selected, and outside the range will be removed. Therefore, for question 3 part 3, the function of h omega is basically a band pass filter, in which it will select components, signal components within passband, but remove unwanted signals. Okay, so this is the function of h omega in this case. And then question 3, 4. Okay, sketch the output spectrum y omega. Okay, so from the figure, from the system, you know that yt equal to mt convolved with ht, the filter. So in this case, y omega equal to m omega multiply with h omega. So the question asks you to sketch. So you have your m omega earlier. So your m omega looks something like this. At 50, you have one sinc function, and then at 100, you have another sinc function. Okay, the magnitude is 1, so this is your m omega. So multiply with h omega, so your h omega is the filter. So you have this one, 20 and minus 20 and minus 80, and also you have 80 somewhere here. So this is your H omega. So what's the output Y omega? Is when you multiply M omega with H omega. So you may notice that this signal multiply with 0, it will be 0. So the rest also 0. And the only selected one is the higher frequency component in this case. So the output you have is this. Here is 100 plus 2 pi, and here is 100 minus 2 pi. So this is your Y omega. In omega, how about the magnitude? So if you refer to the filter, the magnitude is 2. So here is 2. So what the 2 is basically represent? So the magnitude 2 is equal to the output amplitude divided by the input amplitude input. So in this case, our input is 1. So the output equal to 2 times 1. It is 2. Okay, so the magnitude of your output equal to 2. Only one signal being passed through and the rest are removed. Okay, question 3, part 4. Okay, write the equation of output signal YT. From the previous question, we have sketched the Y omega. So in order to get YT, it is basically the inverse Laplace transform of Y omega. So what is your Y omega in this case? So from the signal, it is equal to T to sinc function. So omega minus 100 divided by 2. So in this case, you can compare with the equation. So this is basically equal to, so inverse Laplace transform, meaning that you look at the table and it reverses back. So this is inverse inverse Fourier transform. So it will produce inverse Fourier transform. It is equal to, okay, so for inverse Laplace transform, a tau sinc function omega tau over 2 will produce a rectangular t over tau. So in this case, you have your a tau equal to 2. So a tau equal to 2 sinc function omega minus 100. So your tau is 1. So it is equal to, your a is 2 rectangular t over tau. Tau is 1. So your t, okay, when you refer to the Fourier transform table, when you have shifting in frequency, so in t you'll be having multiplication with exponential function. So multiply with e j omega naught t. So your omega naught in this case is equal to, your omega naught in this case equal to 100. So it's 100 t. Okay, so therefore your yt is equal to 2 rectangular t multiplied with ej 100 t. Okay, this is the last example for today from past year's exam. So given a system of FDM which transmits more than one signal on the same channel without causing spectral interference. So given the input signal, you have N1 omega and M2 omega being processed by having some multiplication and addition with different signal, and then at the end the signal being multiplied again with another carrier signal, so to produce the final output. So these are the carrier signals. So the first one, you need to sketch the spectra or spectrum at points A, B, and C. So A, B, and C. Okay, for question 4A, so sketch the spectra at point A first. So at A, we name it as AT. It's basically the M2T multiplied with 2 cos 10,000 or 10k T. Okay, so in this case, it is equal to 2M2T cos 10k T. So if you refer to Fourier transform table, a function multiplied with cos function, so your A omega equal to 2 multiplied with 1 over 2. So in this case, we have M omega plus the omega naught is 10,000 K plus M omega minus 10,000 K. So this is your A omega. So but the question asks you to sketch. Okay, so the M, or in this case, is M2. So this is M2. So given M2 omega, so but now the omega, one of the signal being shifted to the left and one signal being shifted to the right. So your A omega equal to centered at 1 is 10k. So this is A omega, and then here is 5k and 5k, so 15k and 5k, and the other one, you have this signal being shifted to the left by 10k as well. So negative 10k, so here is negative 15, and here is negative 5k. How about the magnitude? The magnitude is 1. So this is your A omega. Okay, next is we have sketched A omega just now. So now you need to sketch for B omega. So B equal to BT in this case equal to M1T plus, this is the plus AT. Okay, so your B omega equal to M1 omega plus A omega. So we have sketched A omega just now and M1 also given. So now you just need to add them up. So here is your A omega just now. The magnitude is 1, so this is your A omega. And then given is M1 omega, so here is 5k and here is negative 5k. Negative 5k and 5k, so this is 1 as well. So this is your M1 omega. So your B omega equal to A plus M1. So equal to okay, 5k, negative 5k, the magnitude is 1. So plus the A omega. Same magnitude, and same goes to this side. -5, -10, -15. And magnitude is the same, so this is your B omega. Okay, so next you need to sketch for C omega, or C signal at point C. So in this case, C equal to CT equal to BT multiplied with the cos function 2 cos 20 kt. So again, when we have a signal multiplied with cos function, so in frequency domain it is a combination of signal being shifted in frequency both in positive and negative side. So C omega equal to 2B omega plus 20k plus B omega minus 20k. So meaning that from earlier question we have sketched the B omega centered at 0. So now this B omega need to be shifted to the left and to the right by 20k. Therefore, your C omega may look like this. So this B omega being shifted to the right by 20k. So now the center originally at 0, it becomes 20k. So then gap by 5k to each signal, 25k, 30k, and 35k. So here is 15k, 10k, and 5k. And this is the one on the right. So you have another one on the left, that this B omega being shifted to the left by 20k, k to the left. So you have another one. Now it's centered at -20k, and the rest of the values are the same, -5k, -10k, and so on. So how about the magnitude? So the magnitude is 2 multiplied with 1/2. So it's 1/2. 2 multiplied with 1/2. So the magnitude is 1. So this is your C omega. Okay, for question 4b, what must be the minimum bandwidth of the channel? So bandwidth is basically the size needed to fit in one information. So from here we know that complete information can be retrieved by having a complete signal. So in this case, complete signal represented by this shape. So this is basically a bandwidth required because it covers complete information. Okay, so you just need to consider one side because for in communication system, a single-sided spectrum is enough to be transmitted so that you can save more energy, because you may see that the signal on the right and on the left repeating itself. So you just need to transmit one complete information for efficient transmission. So the bandwidth required is basically a 35k minus 5k, so it's basically 30,000. In this case is radian per second. Okay, or you can convert this into hertz as well. Okay, because this is the size you need to consider to transmit complete information. Okay, it will be much more efficient if you can remove this area so that the size of the channel can be more efficient. Okay, you just need to send the information without having any empty space. Okay, from earlier example, we have seen the signal B omega, and then the BT being multiplied with cos the carrier signal at this point. So you get C omega. So you notice that this signal being shifted, the center being shifted to the right by 20k and to the left as well by 20k. So now what happened in this question for C? If this frequency is now 10,000 K only, 2 cos 10 kt. So what will happen? Okay, so CT equal to BT multiplied with 2 cos 10 kt. So if convert this into Fourier transform, so you get C omega, we can say C nu equal to 1/2 B omega plus 10k plus B omega minus 10k. Okay, so you'll notice that the signal of B omega now being shifted to the right and to the left by only 10k. So how to draw this? So let's look at the first one, when the signal B omega be shifted to the right by only 10k. So now the center, supposedly at 0, now become at 10k. And then you have this one and this one. Here is 10k, here is 5k, here is 0 and negative 5k. And here is 10, 15, 20 and 25k. And you have one more signal on the left hand side, in which the B omega centered at 0 being shifted to the left by 10k as well. So you have this signal centered at negative 10k, and this one. Okay, here is negative 15k, negative 20k, and negative 25k. So the magnitude is 1. So this is your C nu omega. So what happened? The question asks you what will happen and explained. Okay, so based on this derivation and based on sketching, so you may notice that the signal at the center is overlapping. Okay, in which supposedly you get this shape incomplete, but now you have part of it complete. Okay, but the center, there's overlapping at the center. Therefore, so if omega C, the carrier frequency now equal to 10,000 radian per second, you may see there's overlapping at omega equal to negative 5k to 5k radian per second. Therefore, this causes distortion of the output signal. Meaning that the efficiency of the system reduces. Efficiency is reduced. So you need to write this one in proper sentence. Okay, so with that, thank you. So I'll upload more examples based on past years and tests and exam. So please do derive the equation yourself. Okay, with that, thank you.